There we go. Well, if you're in the chat, let me know if audio is working, because I really don't know, honestly. And I'll go ahead and get started, turn the microscope on. First thing I gotta do is get the microscope through its warm-up and get the vacuum pumps going so I can actually enable high voltage. The high voltage won't turn on until the columns have vacuum, because you run the risk of shorting out the electron gun, or arcing out the electron gun to the accelerating 1 volt. So let's get that going. Gotta plug this SEM in. Give the fan, you guys watch this. Give the, okay, vacuum gauge alive. I need to check my AC line voltage first, because sure is audio broken. Very funny. One of the problems I have been having is that AC line voltage at my house isn't constant. And when you have, come on, change over. And when you have an instrument that is very, very picky about what it gets for line voltage, making sure it's high enough matters a lot. And I think it might be a bit low today. And if it's low, I'm going to have to figure something out. We'll see if it's high enough, but I don't think this is going to be high enough. So I've got a 60 hertz hum that I don't normally hear when I turn this thing on. The lights? It's not the lights, this is the monitor. It's not the monitor. Where is this hum coming from? This is weird. Okay, finding the humming sound. It's really loud. I don't know if you can hear it or not. Yeah, this just doesn't sound right. It's not there now. There it is again. Huh. This is a bit weird. It's not there now, but I'll try the... Okay, we might actually have enough voltage to pull this off. If it drops below 90 or drops below 100 when I turn the microscope on, then it's not going to work out. I'm going to have to figure something else out, but I don't think it's going to. So let's get the rotary pump going. I don't think I'm going to stay over 100 for this. You might have to adjust some stuff. And I'm going to manually actuate that valve that's broken. There's an O-ring inside the valve that's pretty badly deformed, is what I've discovered. And somewhere around here I have the glove I used to do this, because it's kind of a sharp edge you have to grab to get it to turn. Come on, just did this a couple days ago. There's the glove. Huh. I found the humming noise. There was a solenoid valve that was open. And I just realized yeah, I got a sample in there, it's fine. Okay, let it pump that down for a while. Now just watching pressure. There's a lot of weighting involved in this thing. A lot of weighting. Let's put that back on again in a second, though. Now I'm gonna check current right now, see how low it's gonna drop. Yep, gets too low. Okay. I had to figure out how to increase voltage by about 2 volts to turn the microscope on. Yeah, AC line voltage around here fluctuates from like 117.8 to 119-ish, and if I'm on the higher end of that, I'm fine. If I'm on the low end, then I don't actually have enough power to run the microscope, or enough voltage, because it wants 98 volts, and you don't get 98 volts. A lot of stuff starts to get really upset really quickly. You gotta keep it in between 98 volts and 105 volts is the manual spec. So I've got to think about how to increase voltage being supplied to this thing. And I don't have a variac, so it's probably going to end up being retapping the auto transformer. And then I'll just retap it for like 105-ish, because I can never get... When I'm at 118, when I'm at 118.2, it's tapped for 101.1 right now. I think something similar to that. So that's what I measured. But it's going to have to be retapped probably around 105. But I don't have an option to go from 120 to 105 very well. So I'm going to have to tap it so it's just over 105, and then know that as soon as I turn it on, you'll get a little bit of voltage drop. And I don't like doing that. The little bit of voltage drops, I think, is going to keep me inside of my bounds. And then at a higher voltage too, I'll have less current draw. Yeah, I'm probably going to have to go that route. Okay, so scope off. Diffusion pump off, or roughing pump off. Can't really vent it, the scope's off, so I gotta turn the scope back on. Dun, 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 dun. Okay, so column is evacuated, or not evacuated, pressurized. Scope's off. Transformer is unplugged from the wall. You gotta unplug from the scope too. Okay, we're off the scope. It's gonna be fun moving the camera. Get it far enough over. Increase exposure a little bit so you can actually see something. Exposure. And unplug from the wall, unplug from the microscope, and pull this thing out. So this is the microscope's auto shrink. Stuck on something. Okay. After we untangle a cord, that's the microscope's auto transformer. Okay, got a screwdriver for that. I have one right here, and I'm gonna need pliers for that. I got pliers right here. Okay, and something to rest my knees on. Okay, so I'm going to tap at plus 20 and plus 140. Yeah. And that will give me a 120 volt differential. So that might not work actually. That'd be too low. What's my differential right now? My differential right now is, oh, it's still 120. It's just too low, so I need it to be a bit higher. So I can go 110 volt differential. Should make my output high enough to work. But I need to take a photo of how this is assembled right now so I can remember how to put it back when I need to drop the voltage again, because inevitably the AC line voltage around here will change again and I won't need to increase it. So this is going to get very old very quickly as I have to keep on changing it to match what the town is providing me. Okay. So pull those two. Pull this one. Pull that one. And tap at 100 volts. Tap at -10. So AC line neutral goes to -10. AC line positive goes to 100. Or AC line hot, I should say, not positive. And outputs are going to go to the output terminals, I think. Oh great, my whole output terminal is turning. That's not good. Okay, now I gotta investigate to make sure that didn't damage anything and spinning that around a couple of times. That's my multimeter turning off. Come on. Great. There's a strip screw over here. There we go. We're going to toss that screw out. I don't like dealing with stuff that's stripped. Okay, so in turning this terminal, is any damage taking place? The answer is no, it is not. Okay, that's good. Just gotta tighten that screw down the back then. Why did that happen though? I could actually not use that one because that's tied. Is it tied? It might be tied. I don't know for certain. So you get another pair of pliers and har, Drew. Very, very funny. It is indeed. It really shouldn't be, but it is. And most of my pliers are in the house right now. I just want to see if I can do this without having to go in and grab a pair. So let's see what I can find out here. Also, hello new viewer, feel free to say hi in the chat so I know who I'm talking to. Okay. I also don't think that's good. You know what? Let's not do that. Let's size this correctly. And we're free. Okay. See if that's tight. Hopefully that's tightened up more. Okay, so let's see. Wow, this is really tight in here. I forgot how tight this was. Washer on, thumb screw on. Take that thumb screw off. Oh, Drew, by the way, aren't you in Texas? And isn't it, or how's it going down there right now? I should probably ask. Sure you're okay? Come on, get off there. Washer and thumb screw. Hence the British levels. It's got it. Just a bit damp. That's good. So I'm guessing you're not in Houston. Okay, let's make sure I did this right. Output is at neutral and hot, and input is at -10 and 100. Oh, wait. Shoot. This lifts the entire microscope. "10 volts above ground." Which isn't okay. I've done this before, that's why I didn't do this last time. My neutral always has to be below the output, or on the output. Okay, how did I solve this last time? Huh. How to solve this one? Okay, let's see if I tap at... Let's just see what a 120 volt differential looks like and how high that voltage is. And I'm going to have to watch it throughout the day because inevitably line voltage will change. Which is incredibly annoying, but if you want... Huh. Will this work? Potentially it'll work. I'll just have to make sure I measure all three legs, make sure I don't have any things that are too high above ground. It's not good when all of a sudden your ground, something shorts to ground and it's actually shorted to plus 10 volts AC. Especially when said thing can provide a lot of current. Okay, check, 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 and check. Potentially. Double check. Make sure it all makes sense what I'm doing. Yeah, that should be good. Okay. Multimeter, get it plugged in. no smoke yet.
It's already too low. It's at 98.3 right now. What's my input at? It's at 118.1. Okay, so try stepping that down to plus 10 and see what happens.
If it goes to like 106, 107-ish, I'll be fine. Should very well may. So, unplug from the wall, unplug from the scope, we're good to go. Okay.
How to route this wire cleanly. Get a washer in there. Well, it's supposed to be a lot more interesting than it is right now, so sorry about that. Never know what the scope's gonna throw at me. We'll probably give it about 8 more volts, which might be just 1 volt too high. So we will find out. Okay. No, I don't think it's gonna go bang. I mean, it's all fused, shouldn't go bang, let's put it that way. Okay, it's plugged in. No bangs. And let's check voltage. $90. Oh, of course, because I gave it a higher differential. I need to give a lower differential. Oh, silly of me. What's my input at right now? 18.2 now, it's climbing. Okay, so apparently if I just put it back to how I had it and just wait, I'll be fine. It's incredibly annoying. Can't believe that my line voltage changed this much. I need to get a variac. I got an idea how to fix this. Just make my line voltage whatever I want, or just set my neutral wherever I want. Just set my neutral onto -10, and that will become my new neutral because it'll be there and I'll be fine. Also, hello new viewer. Just figuring out. So right now the AC line voltage at my house likes to change, which is incredibly annoying when your microscope is really picky about what voltage it gets. If it drops below 98 volts, then a bunch of systems get undervolted and everything just starts to go poorly, and it's not good. But with my AC line voltage around here changing, I have to figure out how to adjust my transformer to be okay with that. So this is going to go to 100. That's 100. That's going to stay where it is. This. Going to move to -10, as is this. Volts fall, everything dies. Everything doesn't die, it just gets gets a little bit unstable. Because it's ran at that voltage before, and nothing too bad has happened, but nothing liked it either. So it's okay, nothing's gonna die if I don't run it too long or too often like that, I bet. But it also doesn't run properly. So oh yeah, line conditioner. No, I definitely want to get a like I think even like just a 15 amp APC UPS will be enough to fix this. It's just that it costs money, and well, I have other things such as other parts of the microscope and other things I can have to spend money on right now. So I can't really afford to drop a couple $100 on a 15 amp UPS. But no, they'll definitely fix it. And it's not like I need the UPS for battery power once if the power ever cuts out. I mean, if the scope shuts down like that, it's fine. it'll automatically turn a lot of systems off, so there's not a big inrush current when it starts back up the next time. But I just can't quite afford that right now. I haven't started on Craigslist Fail. Or Craigslist Foo. I've had a fairly busy weekend since I really discovered. I pretty much discovered that this voltage was pretty variable on Thursday. Because I was wondering why everything wasn't getting enough power. And everything wasn't getting enough power because there wasn't enough power coming into the microscope. Which is really annoying, but I mean, things like that, I guess, things like that are kind of to be expected with a system like this. Wait, that doesn't work. Okay, if I wired it like I was just about to, I'd have just all my taps, or my input and output taps in the same tap, which would mean I just basically have a big inductor. So now I have to, okay, that's why I didn't do that before. Remember there's a reason? Let's look something up real quick. Would that work? Yeah, that'd work. And probably it would. Yeah, that'll work. Okay, cool. So put both my inputs, or both my neutrals, on the high side, because that's just where I have the option. It doesn't, with an auto transformer, it doesn't matter. So neutral and neutral there, and then output hot. Okay. I want to increase or decrease differential at that point because it's inverted. So I would decrease differential. Okay. So all of a sudden that becomes plus 10. And that becomes plus 20. That goes to 140. Nope, that doesn't go up there. That goes up there, that goes over there. After it goes under that. I don't really like this power supply, if you can tell. It's a little bit annoying. Thank you, multimeter. Okay, so this wire actually is better routed across the right hand side. So I'll go ahead and do that. So this will go like this. Let's go over there, let's go over there. Okay, so both my neutrals are up top. Now the differential over here. And everything's still where it should be to not get a hot ground. Relative to earth ground, that is. Probably turn my rainer off. Da, da. Okay, that looks right. Okay, let's try that out. Get everything plugged in. No nasty noises. Get it out of DC. 109.5, that's way too high. Okay. What's my line current at now? My line current, or my line voltage must be higher now. Wow, line voltage has gone up by a half volt. So it's back. It's right back where it started, and it's right back where I need it now to actually run the microscope normally. So now I have to put everything back. So the correct solution was actually just to wait till the line voltage changed. And the answer is yes, I need a UPS. Okay, so no, it's fine. It's not a big deal. It's I just have to move one screw terminal. So okay, we're unplugged. We're unplugged. Yeah, I'll have to contact my utility and ask them what's up with this, because it's kind of ridiculous that line voltage changes like this during the day. I'll have to do an Adafruit IoT line voltage monitor to get data from all day long. Just a couple more thumb screws to go and we'll be good to go. Okay. And one more thumb screw and I will be set. Okay, so input, output. Yeah, should be ready to go. Okay. $101.7, that's high enough. Also means my line voltage has gone higher since I last checked it. Yep, line voltage is almost up to 119 now. Or one, yeah, that's really, really annoying. Okay, so I gotta unplug this again. Yeah, and if the thing is, if I think this is difficult, I can't talk too much about it right now, but I have a project coming up that requires a 30 amp rotary 3-phase converter. So you can imagine how much fun that one's going to be. And unfortunately, it's not really using 3-phase for anything that really needs 3-phase. So I mean, it's just kind of an annoying power requirement for it. If it works out, I'll be able to just convert it from 3-phase to split phase 220. And it's like, yeah, there's a motor involved, but it's not. You're not doing enough stuff with that motor to really need 3-phase on the motor. And there's also a heater involved. That heater would run just fine with a single phase if it can be wired for it. All right, split phase. Finish bolting this thing together. Okay, we're bolted together, and I gotta check the output on the cord, make sure that's good. Okay. I'm just about confident. Output's is good. I just have to check one more pin. Output's good. Sweet. Well, thank you, local utility, for making life annoying. Also, hello, new viewer. The stream is about to get significantly more exciting than it currently is, because I won't have to deal with my utility changing line voltage. I mean, I'm sure they don't mean to, but it's still really annoying. Hello, Cedar. You joined just in time. Just in time for the fun stuff. Okay, that's all hooked up. Make sure... I don't get any cords tangled up in anything. Okay, that cord is clear. Pump's clear. We'll leave the transformer there for now in case I have to come back to it. Glad you had a good time finding the correct size hardware. It's always fun at the hardware store trying to, or at least around here, trying to find really small metric sizes. That always seems to be a challenge. Okay, let me check all my stream settings, make sure nothing's going too bad. Okay, everything looks good. Oh, just about yanked the webcam off. It got caught, cord caught around my chair. Oh, that's clever, getting the ice screws from the doctor's office, or eye doctor's office. Okay. That should be a little bit less overexposed. And go ahead and power it up. Well, you have to be plugged in first for that to work. I can plug in the roughing pump at the same time. Okay, roughing pumps on scope. Pull in a vacuum. And now I wait. Okay, gotta make do. Well, feel free to ask any questions while I get this going. Gonna be waiting on the pump for a bit. I have it's fast. It's way faster to let it pump down with roughing a lot of the way. So so that's what I'm going to do. Yeah, there are a few cities where you don't have to make do very often, but not nearly that many. Should probably drop exposure a little bit more. Ultimate pressure, we're looking well under 0.1 micron. As far as roughing pump pressure, looking for about 60-ish microns. But my scale doesn't read out in microns, it reads out in random arbitrary numbers. So I just get my scale about halfway and then hit the roughing pump. Well, that's halfway. Time to go actuate the roughing pump valve, which is normally really easy, but I had an O-ring that got there's an O-ring in there somewhere that's deformed. Which means at some point I'm going to have to fix it, but that requires taking apart the valve body, which isn't the easiest thing in the world to do. So in the meantime, the valve just gets manually actuated. And apparently there's some air caught inside the valve body when I actuated it, so pressure dropped again, so I have to let that come back up a little bit. Well, diff pump's not going to be warmed up yet, so diff pump on. Water chilling on. And the waiting game for 15 minutes. Look, it's boiling a bit of moisture out of the oil. Let that climb again before I hit it again. Stays above 50, I'm fine. 50, some random arbitrary number that I don't know what it means. So, well, I mean, I know what it means. It means the point on the scale, I just don't know what pressure it correlates to. And there's not really a convenient spot to put another vacuum gauge on. So I'd have to kind of machine an adapter to do that. I don't really want to do that. And I can't just replace the current gauge because the current gauge is tied into the logic circuitry in the SEM. So a lot of stuff will automatically shut off if it doesn't detect any signal on the gauge. Feel free to ask any questions right now while we wait. Meantime, let's check Craigslist for UPS real quick. UPS. 450 watts for $40. That's not enough. UPS electric yard sign. That's not what I'm looking for. 350 watts. So new. Oh wow, these are. These are expensive. Let's look at a power conditioner instead of UPS. Not big enough. Wow, 1.5 amps output in this one. That's really impressive. Okay, pressure still, or climbing. Pressure still dropping. Not really climbing. Let's see here, this thing. Oh, this one just disconnects equipment from the power when it drops outside of safe range. Let's see here, what else is available? I guess just a variac's probably the way to go, just because of the price and how big a UPS you need to do what I want to do. Yeah, there's not really any good options on Craigslist right now for the size of either UPS I need or for a variac. So eBay. Not too bad on eBay. I'm looking at 90 bucks. Actually, most of these are too small in a size. There's one for 100 that's the right size, 20 amp. I need a 15 amp UPS, and that costs about 850 bucks on Amazon. And I just need a UPS because the line voltage around my house changes. I don't need it because of power conditioning or anything like that, except just to keep line voltage constant. Yeah, most UPSs just aren't that big. Okay. Well, I am at operating pressure. So give it another 5 minutes and I will be ready to go ahead and hit the high voltage. Four more minutes. How many watts do I need? About 1800. Yeah, motor generator. I thought about doing that, but I have to get a synchronous motor, and those aren't the synchronous motors aren't exactly cheap. Because if I don't get a synchronous motor, then the speed's going to change with yes, speed would change with voltage supplied to it. Variacs aren't that expensive though. Dun, dun, dun. Almost there at the high voltage. Should probably get my probe set up. Make sure I probe on the correct probe point. Yeah, that's probably always what it's supposed to be. If that's for your silk screen, or your... Oh, it's probably for your UI. Yeah, no, just put SD in the middle and it'll be really, really obvious. Okay, so I need to be on test point. CP3? I think. Oh, do you not have text you can put in it? Well, high voltage ready to enable. So, first of all, I gotta set a fan up here because it's getting kind of hot. So, you do have an extension cord for the fan. Nope, but I got a power strip. Which will work as an extension cord. How's this for an extension cord? Well, sorry about the fan noise, but I need it in here. Looks very Intel-esque. Yeah, a lot of stuff in my shop's Intel-esque right now. It's about to get a lot more when I get all my new workbenches moved in here. Okay, let's increase exposure for you guys. And let's give her some power. Okay, got an image on screen. All my probe points are clear. Get the oscilloscope on. Yep, noise is still there. Though nothing else seems to not be working, so that's good. Once I get the scope on, You can see just kind of, it's not very, here, let me zoom in some, and it'll become a lot more regular. So you can see the noise is fairly regular. So it tells me that it's not just something random going on, but a component failure somewhere. Power conditioning is 120. But I need more than, I really need it to be a kind of isolated conditioning. I can't just have it eliminate sags, temporary sags and peaks. I need it to actually just give me 120 volts out. Okay, so noise is still there. Got a probe point I want to work on, I think, but I need to make sure I don't have any high voltage present there. Well, let's put it this way. It's coupled to ground through a 25 volt capacitor, so I should be fine. Right, it's coupled to ground. Say, I might not see the problem now. We'll find out. Firma, okay. I'll check that out at some point, but Firma AV74. I'll switch it right now real quick. Oh, you know what? I've actually used these before. I didn't have to buy it myself at the time, though. Yeah, price isn't too bad. That's from Granger, so it's probably a bit expensive from there. No, same price somewhere else too. Okay. Yeah, I'll take a look at that. Anyways, let's shut this down so I can do probing safely. Give the capacitors a bit to calm themselves. Make sure I know where I'm probing, which I do. Yeah, let's see if this is indeed the problem. Okay, time to probe. Just sat on, whoops. I sat on a broken PCB, which is good that's broken, but not good that I sat on it. Okay, get some power. come on screen, come on. No, it won't come on screen, okay. Okay, let's give it some power, see if anything changes. It doesn't look to be the problem, which is weird. So one of the things with this is that I wait for backscatter to come up, or for voltage to come up before I can show you this. Yeah, better than stepping out later, that's for sure. Is that okay, so I got the image on screen. And I'm in the 5000 kV accelerating range right now, and I'm in secondary electron. Turn it to backscatter. The random noise just really isn't there in backscatter mode. So you see the image looks relatively normal in backscatter. And unless there's a scan circuit somewhere I'm not aware of, the only difference between backscatter and secondary is that literally a relay opens up on the high voltage side and it just shuts one part of the high voltage off. But from the oscilloscope reading, it looks like that part of high voltage is actually working relatively normally. So, let's just try this out. Get into free running. Well, this is weird. Okay, let's see. Well, this is telling. My micron marker is showing up in the wrong spot on screen. It's showing up here, where it's not supposed to be. I think it is. Well, apparently not anymore. Okay, it's not there actually. Okay, it's not inverting, so voltage. Yeah, I just don't. I was expecting to see fluctuating voltage on the output of the of this voltage rail out there. I'm just not seeing it right now, which is means the problem is somewhere else than I think it is. So where could the problem be? Well, let's check the schematics and see if there's any difference in between when it's running in backscatter and when it's running in secondary beyond just enabling and disabling part of the acceleration grid. That's the wrong schematic. That's the schematic right there. It's inside of another one. Okay. That's also the wrong schematic, actually. I need the image control or image processing unit schematic, or the display console schematic. Here we go. Okay, so when secondary electron is active, I don't think the scope knows the difference besides turning off that relay. Yeah, the only thing it does different is turn the relay off to the high voltage supply to that simulator. And when I say relay, I mean there's a really small oil tank in a microscope with a relay in it for the simulator, high voltage. And the only difference between simulator high voltage and the only difference between on and, or when it's in secondary and backscatter is that the simulator high voltage is on or off. Which means, and because the output from that high voltage supply looks normal, and to be what I would expect, but the problem wasn't where I originally thought. I do have a spare one of those units that I could mount up. So I thought this was going to be a component problem inside the flyback driver that supplies this high voltage rail, and it's not looking to be that right now. Unless there's another place that it's switched off. Or unless there's something else that's switched. But I just don't think that's the case. Yeah, that's just not what happens there. Maybe this switch has a second conductor on it somewhere? Okay, the switch is actually in two different spots in the schematic, which means it's got a second conductor that goes somewhere else, so I gotta trace that too. Okay, let's check this out. Okay, where does point 16 go to? Huh? 16's a ground. Why would it go to a ground? What is up with this? This is weird. Okay, I gotta turn this fan off real quick. It's blowing away my schematics. Okay, you know, let me change some exposure settings so you guys can actually see the schematic. Okay, so what's going on here is that on the front control panel, I've got secondary electrons and backscatter electrons. When I'm in secondary electron mode, I'm detecting more electrons than when I'm in backscatter, because it's just the different ways that are generated on the scan sample. The way you change that is you change the energy level of the electrons you're detecting. So what you do is you just turn off high voltage to the scintillator supply. And the scintillator, basically, whenever it's hit by an electron, it turns that electron into a photon, and then that photon is turned into a voltage by the photomultiplier tube. So by turning into backscatter, it turns off a high voltage relay inside the microscope that then doesn't supply that high voltage to the scintillator anymore, so that you detect a different electron. So when I'm in backscatter mode, my image quality is significantly better than when I'm in secondary electron mode. I don't have that horizontal scarring problem in backscatter mode. So on the schematic, secondary electron and backscatter electron are right here. They're switched here and here. This first switch, as far as I can tell, it's a weird schematic it's a weird diagram for a switch. Just goes to the high voltage tank in 2 spots. So I just don't see how it could at all change the image quality. But it also goes up here, comes down and over to here. And I don't know what switch 8 does. That's switch 8 right there. Reduce? That's not a... Reduced area? So that's probably reduced area right there, but then I don't get what happens after that. Just a second, guys. Hello?
What are you guys doing?
Working on a project.
Why can I not come in?
Because it's dangerous in there. Well, it's not that, it's not really dangerous. It's just I just working on my own project right now.
Can I come in with mine?
Unfortunately, not right now. Do you live over there?
No. I live in Japan.
Are you just here for a little bit then, or what?
My cousin's over.
Are you staying over there though?
No,
No, just make sure you head back to where you're staying, okay?
you even have a pool.
Yeah.
Not know that.
Well, that was interesting. This is why I don't give out my address on the internet. Yeah, you're right about that. Cops are not here. There is a... I don't know if it's a cousin or a brother or something. Our neighbors have some little kid over, and so the little kid... My garage door for the shop's on the other side of my property. So the kid was out there banging on the door asking what project I was working on. So probably can't see anything on the webcam right now because it's face down on the table. Get that mounted back up. How's that for a bit of neighborhood excitement? Oh, great. The schematic's waving all over the place the whole time. Okay, fan needs to go off now. And let's figure out where this thing goes. Let's see here. Switch 2. Switch to 7. I mean, where is switch to 7? I don't... I'll be back again, guys. Okay, I'm back. You can see that. They're not in my yard. The garage door faces an alleyway behind my house. Okay. Back to switch 2.7. I just don't think it's a switch on the front of the control unit. I think it's somewhere inside the control unit. So I'll look at my other control unit. I don't think it's on the front panel. Could be. I don't think so. Unless switch 2 is gamma control or something weird like that. So switch 2 has 4 positions. Are there any 4 position switches on the front panel? That's 5. That's 4. That's scan mode again. Could it be that switch to a scan mode? Scan mode has enough. I guess in theory it could be scan mode. It's the only 4 position switch on the front panel. But it'd be really nice if they label that switch as being scan mode in more than one spot. Okay, so scan mode is indeed switch 2. 11, 12, 13, 14. But it just switches it to a ground. . Okay, connector J and 14. Where does J and 14 go? Because of course they're labeled differently on the back than they're labeled on the front. J and 14 external beam control? Why would J... J114 was an add-on done by the previous owner of the microscope. It wasn't there originally, so I don't know why. Well, J114 shown is not connected in these schematics, so that I guess that makes sense. Huh. Okay, anything else on switch 6.2? Okay, what changes when backscatter or when secondary electron is disconnected? What changes then? Pin 34 changes, and pin 34 is on connector... JN14, which once again, JN14 doesn't go anywhere. I mean, it's gotta do something. Okay, 21, where's 21 go? Where's 45 go? Guess they both go. Oh wow, focus has been really bad, hasn't it? Oh, I guess it's better now. Okay, this problem is making less and less sense as time goes on. Which isn't how you like problems to go. They must are really not like the people who had to service these things very much. Okay, I'm leaning in a different troubleshooting direction right now that it might actually be a physical contamination, potentially, of the scintillator itself. Or maybe a vacuum leak or something around the scintillator. I honestly thought this was going to go in a really different direction, so that's why I started streaming, because I thought I kind of had an idea where the problem was, but I guess not. Let's see. Really, right now I'm just playing a game of following lines across a piece of paper. And connector J on 4 should be the high voltage. Disconnect. Which it is, and it goes to pins J and I, one of which goes to a voltage rail, and the other of which goes to the relay. So being that it goes to the relay, So how does the scope know in X-ray mode when to disengage stuff? It knows because it How do you know? Because when you select X-ray mode, it starts to pull a signal out from somewhere different in the electron microscope, so I just want to see where that bit of processing is done. It's not going to be in the horizontal suite. It's going to be somewhere else. Dun, 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 dun. Huh. Does it pull a pin high somewhere? Why is this thing so weird? See you later, Drew. You're probably not gonna miss much. Just me staring at the schematic for about another 40 minutes till I find the problem. Okay. I mean, I could just swap the scintillators out and rule out the scintillator being an issue. Assuming my second scintillator is also good. Check the manual scintillators. Page 20. Or section 20. Use for a simple option, similar light replaces similar captain. So, reading the manual, it could be a bit of contamination, and it gives me an easy test to do. So, let's see here. Vacuum's good. With instrument enabled. Leave that in counterclockwise. Turn light on. Adjust brightness to comfortable level. Okay, no change between the two. And turn the... I wonder how regular those dots are. Okay, so... Let's see here. Set the contrast control in 2 or 3 o'clock position. Adjust brightness to a comfortable level and turn. Okay, so that's not an issue. So I have good contact scintillator. Is it even probed in the right spot? I just moved my probe to somewhere that should give me a better indication of what's actually going on. Okay, let's give it some voltage. Or give it some current. So I'm still seeing the noise pattern. You know what? These little specks... It could be that the scintillator's not working right. I could have some sort of capacitive effect with the scintillator right now. And it's just spewing out photons and it's not supposed to. Wow. I need to check what's going on with the physical scintillator itself, but this pattern's so regular. Huh. Okay, so that's happening just over every 1 nanosecond, or 1 microsecond. Probably about 1 1/4 microseconds. And if I go ahead and give it some voltage, then my noise is happening on approximately the same interval. Yeah. Approximately. The noise is a bit more variable. Which is weird. So it's not noise, it's more deterministic than that. You guys see the scope okay? Yeah, you kinda can. Should probably turn lights up a bit. Or turn exposure up a bit. Come on, focus. I know you want to. There you go. Okay. So as contrast is increased, the interval of the noise stays right about the same. But why every 1 microsecond? It's like almost dead on. There's noise every 1 microsecond. I have to learn more about how the contrast control actually affects the microscope. Let's check the troubleshooting section to see what it has to say about contrast control. Yeah, I don't know what the scintillator bias's voltage is. That's what I'm checking on right now to see if there's a 1 megahertz signal in there somewhere, which would be really telling about it. You see, changing contrast control is what makes the noise apparent. And so I'm interested in what contrast actually does. Like, what because I know it's not a signal processing thing. I know it's a physical thing somewhere inside the scope. As in, like, it changes the voltage on part of the detection apparatus. Oh, great. This is something that goes outside my range for what I can probe. It goes up to 700 volts. Okay, let's see here. It appears... Where's the diodes for this? How's this driven? Okay, so this goes through a big transistor. Whoop-de-doo. And that transistor's got some pretty hefty traces. I just don't know where this thing's got a 700 volt recidified DC supply on it. No, the changing the contrast control adjusts the voltage on adjusts the voltage somewhere right here actually, and it changes it between -300 and -700 volts. Which it's inside of the photomultiplier. But you know what? Changing the contrast only makes it more visible. It doesn't necessarily make it more likely for the noise to be there. Because the noise is there, just more visible as I increase contrast. So contrast is fine, which means the photomultiplier is fine. And because I don't get the noise when I'm in the backscatter detection range, it's not contrast. Contrast is just what makes it visible to see it. Because I'm basically making the photomultiplier more powerful by turning contrast up. Okay, so we're moving in a good direction now at least. So I've rooted out the photomultiplier, and we're back onto the scintillator. And the scintillator could itself just be wearing out over time. I mean, it's old. I've accidentally run it in the atmosphere before. It could have got dust on it. It could have been burned in. There's any number of things that could have happened to the scintillator, and I think I have a spare scintillator already set up. Yeah, I've got a spare scintillator already inside. Okay, so it's not contrast control. Hmm. Where could this problem be? Probably is this layer. Let's just look online and see if anybody else has any photos of what a scintillator failure in electron microscope actually looks like. So if I could just find somebody who knows what it looks like when a scintillator is failing, or is willing to post a picture of it, then it'll tell me how it's going for me. Okay. Okay, if somebody just wants to find a photo of this, that'd be great. Hmm. I guess trying to investigate scintillator, see what's going on with that. Still, the fact that this noise is at 1 kilohertz seems suspicious. It just does. So, show me a photo, somebody. But I mean, so the manual calls out horizontal lines in the scintillator as a failure, as an indication of failure for it, and the horizontal lines go away as when I turn off the voltage to the scintillator. 1 nanosecond, 1 millisecond between pulses. It is, yeah, it's 1 millisecond. Or approximate, it's not exactly. I think 1.1 megahertz. Or 1.1 milliseconds. I just don't know what kind of power supply failure this would be. Why would this result in... I don't think it's signal processing. The signal processing path doesn't change in between backscatter and secondary. The only thing that changes in between backscatter and secondary is the scintillator high voltage being turned off. And as far as I can tell, with the tools I have, the scintillator high voltage looks healthy. So I don't get why there's a potential failure there. Let's keep reading. No, there's no voltage doubleator on the scintillator crystal. The scintillator actually, that power supply runs at 8 or 16 megahertz. I know it's running. It is running at that, I believe. Yeah, there's an inductor on the board. It's that one that got really hot. But I mean, I've checked the output from it. I've got a, I got what I believe is an output from it. And I checked that and there wasn't any problem. But the scintillators fail in kind of the way where it would... Yeah, no, it's driven out the 16 kilohertz flyback. That's where that gets its high voltage from. Or one of the... There's two 16 kilohertz flyback. 16 kilohertz flybacks, and it gets its voltage from one of those. Oh. Okay, let's see here. Well, it could. I think it's something. I think it's something to do with the scintillator. I don't think it's the high voltage for it, because the high voltage that powers the scintillator is the same exact high voltage that. Well, I mean, I guess okay. Okay, I got an idea for a test to do. Current down, operation on. Let it warm up a bit. Good scan. This is interesting. One, two, three, four. I think that we might actually have a No, so I can detect that 1 kilohertz pulse noise coming all the time, but it's only bad and it's only affecting image quality when the scintillator is on. And the noise varies when the bias is changed. Well, the noise becomes more visible when the bias is changed. but it doesn't change beyond just the magnitude of it, which is kind of expected for it to be. Oh, well, that actually rules out signal processing, because changing contrast doesn't change your signal processing at all. It only changes the photomultiplier too, which is good. Okay, cool. Thank you for that. Yeah, so noise varies when the bias and the photomultiplier is changed, only in the fact that it becomes brighter. So, like, see the screen right now, and I increase contrast, which increases bias. You can just see it becomes brighter, but the noise is effectively the same still. But something I just observed. If you have any ideas, throw them at me right now. That's... Where's the 8 kilohertz drive for this thing? Let's make sure that's intact. Yeah, I've got a brief text description in the manual of what a scintillator failure looks like, and it just says horizontal noise. It's what you look for scintillator failure, and I mean I've got horizontal noise. Oh no, the only time I don't, I have the image on screen. The only time I don't see when I can just isolate the noise is if I just crank the, if I just leave the accelerating voltage off. No, I've got it. I mean, you can look on the webcam. I mean, there's an image on screen right there. That's the IC chip, and I can rotate it and move it around and whatnot. And it's just that the if I go to backscatter, then the problem pretty much goes away. I mean, you can see the image looks great in backscatter mode. I don't really trust. I mean, I've seen so many different recommendations on how often to replace this insulator, and a lot of those are by manufacturers. So, I mean, I got one I can put in it. Probably should. Don't want to because they're expensive. I like backscatter mode. It's just working beautifully. No, optical path doesn't change at all in backscatter. It just turns off the scintillator high voltage and it just detects lower energy electrons. Or sorry, higher energy electrons. There's fewer of them, but they're higher energy. Oh, TV scan mode works. Never happened before. It's got that noise, but I mean, it works. Okay, Daniel, is anything dying now? Should sound better. Better, cool. Okay, so the noise is only present when the scintillator is turned on, like that. Here, I'll go ahead and bring the webcam in. So scintillator on, we get that noise, and those spec noise. I can't even tell what emoji you used there, Daniel. That the specks of noise are at the same frequency that the noise is at when I go ahead and give it an image. So the end of those horizontal scars, you see, are the same frequency as those specks, and those specks go away completely when I'm in backscatter electron mode. So then backscatter, the scintillator is turned off. So the problem is with the scintillator or the scintillator power supply, the specs and these aren't at the right frequency for it to be related to the scintillator power supply. It's probably just I don't understand how scintillator works, and this is probably what a scintillator failure looks like. So I should probably just go ahead and replace the scintillator entirely. Huh. Okay, well I think I've learned enough to shut the scope down for now. And I guess do an inspection on the scintillator. If I had a high voltage oscilloscope probe, I could just check on it. Just one of those costs. Oh no, you're fine, Cedar. Just fine. Just thinking about what step I want to take next. This would be really, really convenient if I, I can just measure the output on it, but that's really hard to do with an oscilloscope, measuring at high voltage. I think at this point I should just try out my second scintillator. I'll have to go grab that inside, but I guess I'm gonna have to do a scintillator exchange on this. And if it fixes it, or if it's different noise, then that tells us something, and if it doesn't, that tells us something else. Yeah. Yep, I will be back in a couple minutes with a second scintillator. Okay, I'm back. So, interesting discovery. I've got like 5 scintillators, 2 of which go to this microscope. So, usefulness of all 5 of those is debatable. I don't know where the other ones came from either. But in the meantime, I've got another full assembly right here. I don't remember why I didn't use this one. I think there was a reason, so I want to just check over all of the cables, make sure I don't see any visible signs of damage, which is good when they're 10 kV cables. Well, they're missing the strain relief, but I guess it's okay. Let's see. There is a bit missing from this one, but all in all, the surface looks pretty okay. Go ahead and clean it up quite a bit. Yeah, I guess I'm doing a scintillator exchange. That's not exactly going to be easy. Yeah, no, this is pretty involved. Should probably go eat dinner before we do it. Yeah, this is gonna be a couple hours. I don't want to stop in the middle of it because I've got to. Wow, the photomultiplier is already like 3 different steps to disassemble that, and each one of those is pretty involved. So I gotta get the photomultiplier off, get the old scintillator mount off, get the old cage off of that one, get this thing mounted up, get the photomultiplier adapter mounted to this, then reverse the 3 steps to mount the photomultiplier, and then go from there. So yeah, that's at least a couple hours of work to do it carefully. So I really don't want to break any of my parts because I don't know if I can replace them. Well, I guess then for now I am going to call that a stream. If I have the energy when I come back out here, I'll go ahead and do another stream. But with that, I will see both of you later. Potentially tonight, if I have time, but I don't want to do another 3 hours of streaming right now. So, see you guys later.